Hi guys, let's take a look at this question where we have two small spheres A and B made of pure zinc are 0 0.1 meters apart on a wooden table. Sphere A is negatively charged and is free to move on the table, while sphere B is uncharged and fixed to the table, as shown in the diagram below. High intensity ultraviolet light of frequency 2,8 times 10 to the power of 16 Hz is now shown continuously onto sphere B. The work function of zinc is 6,63 times 10 to the power of negative 19 joules. 10.1.1. Define the term work function of a metal. So, work function is the minimum energy that can eject electrons from a metal. 10.1.2. Explain using a suitable calculation why the ultraviolet light on sphere B will eject electrons from its surface. So, how can we do this? We can say that, look, I'm going to show you where E is greater than the work function, right? Electrons will be ejected. So, if we can show that E is greater than the work function, then electrons will be ejected. So, I'm going to use this formula. So 10.1.2, H is a constant. So I'll just get my H constant there, Planck's constant. 6,63 times 10 to the power of negative 34. And I'm going to multiply that by the frequency that was given of the light. And I put that into my calculator and I get a whopping 1,86 times 10 to the power of 17. Okay. And that is going to be greater or less than the work function. That is going to be greater than the work function. Therefore, electrons will eject from the surface. Okay. 10.3.1. Sphere A carries a charge of negative 5,4 times 10 to the power of 6 coulombs and requires a minimum force of 0,027 newtons to move from rest. Calculate the minimum number of photons of ultraviolet light that must strike sphere B, which will cause sphere A to move from the rest position. Okay, so we only have the charge of A, so we'll have to go first calculate the charge of B, because we need to get the number of photons. So remember, to get the number of photons, we use this formula. So we need Q of B, all right? So we first have to go find that. So I'm going to use my formula from electrostatics to go find that first. So they've given me the force, the minimum force required, which is 0,027. K is a constant. K's constant is 9 times 10 to the power of 9. So 9 times 10 to the power of 9. Q1 has been given as negative 5,4 times 10 to the power of negative 6. And we want UB, right? And the distance that they are apart is 0.1 squared. So I do my math calculations and I get QB to be 5,56 times 10 to the power of negative 9 coulomb. So now I've calculated my Q. So now I can use my formula to get the number of photons that must strike sphere B, because I have the charge of sphere B, which is 5,56 times 10 to the power of negative 9. And the charge of my electron is constant, and that is going to be 1,6 times 10 to the power of negative 19. And I get my charge, my number of electrons to be 3,47 times 10 to the power of 10. All right. And that's it, guys. See ya.